The absolute value or module functions. Function. Now the absolute value of a function is defined as, or if we take the absolute value of x is x if x is greater than 0, and the absolute value of x is 0 if x is equals to 0, and the absolute value of x is negative x if x is less than 0. Here, negative x means this is not negative, this is a positive number. For example, this is the negative, and x is also less than 0, so negative times negative is positive. So, for example, the absolute value of negative 5 means this x is equals to negative 5, so we take negative of negative 5, which is equals to 5. So the absolute value of 5 is also 5, and the absolute value of 0 is 0. So in the definition of absolute value, every time the absolute value cannot be a negative. The absolute value is always positive or 0. So if we take this function, for example, the absolute value of x plus 2 is equals to 5. If I take this example, x plus 2 is equals to 5 means this x plus 2 should be 5, or x plus 2 should be negative 5. If this is negative 5, we can have 5. If this is 5, we get 5. So x plus 2 is equals to 5, or x plus 2 is equals to negative 5. So we have what? X is equals to, subtracting 2 from both sides, we have 3, or x, subtracting 2 from both sides, we have x is equals to minus 7. Minus 7. So our answer is x is equals to 3 and x is equals to negative 7. So just you have to check your answer. If you substitute 3 here, 3 plus 2 is equals to 5. And if you insert negative 7 plus 2 is equals to negative 5. So the absolute value of negative 5 is 5. So the other example is, if we take 2x plus 1 is equals to negative 3. This is the other example. Here we cannot find any x which can give us negative 3. So the absolute value of 2x plus 1 cannot be negative. So the solution set is empty set. And next we will see about the graph of the absolute value. Thank you so much. Okay, the graph of the absolute value. So this is the function f of x equal the absolute value of x. Of course, the absolute value of x, f of x equal the absolute value of x is a graph, and we will draw the graph of this function. Just first, to draw this graph, let's take some uh, table. Let's take this. If this is x and this is f of x, let's take negative 2 and negative 1, 0, 1, and 2. Now we know that the absolute, if we insert x negative 2 here, the absolute value of negative 2 is 2, the absolute value of negative 1 is 1, the absolute value of 0 is 0, the absolute value of 1 is 1, the absolute value of 2 is 2. Now we can draw our graph like this, like this, like this. This 1, 2, 1, 2, negative 1, and negative 2. Here, when x is 0, the value of y is 0. We have here, this point is 0, 0. And when x is 1, y is also 1. So we have here this point. When x is 2, y is also 2. When x is 2, y is 2. So here we have. And when x is negative, y is 1. Here, this point is negative 1, 1. And when x is negative 2, y is also. When x is negative 2, we have 2 here. So we draw our graph like this. Our graph is just like this. This is the graph. So from this, what's our domain? Our domain is the sets of real number. The sets of real number. So we can find any number. We can insert any number in X. So there is no number which can give us undefined. If we take any number, you can have positive or zero. So if you take zero, the absolute value of zero, so you can take any real number without zero. If you take a positive real number, you get a positive. If you take a negative real number, you take a negative. So these are sample points. So the domain is the set of real number, and the range of the function is about this. So it is from 0 to positive infinity. So the graph is symmetrical with respect to the y-axis. The graph is symmetrical with respect to the y-axis. Symmetrical with respect to the y-axis. The y-axis. That means the y-axis divides this graph into two equal parts. And the other one is the graph has a sharp corner. Has a sharp corner. Has a sharp corner at 0 0 at 0 0. And the other one is of course our graph is the continuous graph. So these are the properties of the domain in sense of real number. The range is from 0 to positive infinity, and the symmetrical with respect to the y-axis, has the sharp corner at 0 0, and it's continuous graph. For the graph of the absolute value, this one. If we have this graph, for example, if the absolute value of x plus 1, just you have to move 1 unit to the left, it becomes here, and then you can draw. If we have the absolute value of x minus 1, you move this graph to the right 1 unit, it becomes here. Thank you. We will see the other graph next time.